Hello everyone. In this particular video we're going to take a look at three items. One is the confidence interval applet that we were having trouble with on Friday. The second thing that we're going to take a look at is the interpretation of confidence level, those three different statements that you had to analyze. And the third thing is an old AP free response question from the 2011 test Form B, question 5. Let's begin with the applet. I'm just going to hit sample here and we'll see what appears to happen. It appears that I've created a confidence interval, and notice there's a vertical line here at mu. That's our population mean. So this particular interval would have captured the true population mean, or the true value of the parameter. Let's do another one. That one also captures the truth. It crosses this vertical line at mu. This one was off. So right now I'm 2 for 3, or 67% success rate here in capturing the true value of the population mean. And let's just go to sample 50. So we can see here that I've sampled 50, 3 actually in total. I've got 91% that have captured the truth. Let's do another sample of 50. There's 94% have captured the truth. So 97 out of 103 and so on. And you can see that eventually, as I do this more and more times, this settles down to around 95%. Fairly close to 95%. Let's see what would happen if we change these to 90% confidence intervals. So, oh, wait a minute. Back to 95%. Huh. Narrower, wider, and even wider. Let's reset this. Let's do an 80% confidence interval for a second. Let's see, 80%. That means that I'm not even going out 2 standard deviations, so the interval will be very narrow. But notice I've only have a 74% success rate here, or 77%. I mean, 77%, 80% confident. I'd rather be more confident, which means I'm going to have a wider interval. So the wider the interval, the higher the level of confidence. Let's take a look at those statements that we were looking at earlier. So we had a scenario where we were looking at the average amount of sleep adults get each night, and we formed a confidence interval. It was a 95% confidence interval for the mean hours of sleep adults got each night. And the first statement is wrong because it's not talking about the adults themselves, it's talking about the average amount of sleep, the mean sleep. Now I know you might say, well, it has on average here, but it's not about the percentage of adults that are getting that amount of sleep. The 95% confidence is referring to the fact that if we constructed many confidence intervals like that one, based on that same sample size, 95% of them would capture the truth. So it's not about the adults individually themselves. Down here, there's a 95% chance that a single adult, once again, this is almost actually the same as what we have here. It's not about the adults themselves, it's about the average amount of sleep that all adults get. Question C here, there's a 95% chance that the mean hours of sleep, now this is better because it's talking about the mean hours of sleep, but once again, it's not a 95% chance. And a lot of you actually got this right. You said it's either a 100% chance or a 0% chance for a particular interval. The 95% refers to what happens in the long run as we construct more and more and more of these intervals, just like we saw in the applet a little while ago. And then 95% of the time, adults get between, well, that's kind of very similar to what A looks like it's saying. It's clearly wrong because it's not 90% of the time the adults get between these amount of hours of sleep. Once again, it's about the average amount of sleep. So I hope that helps a little bit. The correct interpretation of a confidence level would be that I'm 95% confident that the true mean amount of sleep adults get is between 5.8 and 8.2 hours. And I know some of you pointed out that I did my arithmetic wrong and it really shouldn't be 8.2, but that's all right. All right, let's move on to our last item that we're going to take a look at, and this is the 2011 AP Statistics Free Response question from Form B, question 5. And so at this moment, you should pause the video and give yourself a chance to read the problem and try to solve the problem. If you need to use your textbook to look up any formulas or look up values in a table, you should do that. Hopefully you've had a chance to take a look at this problem. And the one thing I notice here is we're talking about forming a 99% confidence interval, and I know it's for population proportions, and eventually we're going to be forming confidence intervals for population means and also confidence intervals for slope of regression lines. But let's see what we have here. The first thing we want to do is identify what it is we're doing, and we're doing a one proportion z-interval. And I need to identify my conditions. Did you remember to do that? That's a very important step. So random sample, it was stated random within the problem here. We can see that. Random sample. And then the next item is the at least 10 successes and 10 failures. Since we had 978 people that were vaccine eligible get the vaccine, and 1,372 not get the vaccine. Those are both larger than 10. So we have at least 10 successes and 10 failures, which means we can use normal approximations to calculate probabilities. And our 10% condition is met, sampling without replacement. There's definitely more than 23,500 vaccine eligible people in the United States. So here's our formula, and I'm showing also the substitution into the formula. P hat plus or minus z star times the square root of p hat times 1 minus p hat over n. N's our sample size, 2,350. And the number of successes we had was 978. And then the 0.416 number here, that's what we get when we take 978 and divide by 2,350. And the number that you might not be sure where it came from is this number here, 2.576. But as I pointed out today in class, if you go to your textbook, that is not the textbook. Hold on one second, let me find it. Here we go. If we go to our textbook and look at table B, we can see that there are many different confidence levels down here at the bottom, z-star values, and we wanted to do a 99% confidence interval. That's 2.576. So that's where that 2.576 value comes from. And so we do this calculation, and we get a lower bound of 0.39 and upper bound of 0.442. We could also do this on our calculator under second, well, not second stat, just stat, tests, one proportion z interval, option A, and the number of successes was 978, and the number of people in the random sample was 2,350, and we want our confidence level to be 99%, and we go down to calculate. So basically your calculator is just substituting the numbers into the formula and doing the calculations that you would have done otherwise. Right. And the one thing that a lot of times people will forget to do is actually do the interpretation of the confidence interval, and then also forgetting to comment on this belief right here that 45% of the flu vaccine eligible people had received the flu vaccine. So first the interpretation. The interpretation is that I am 99% confident that the proportion of vaccine eligible people in the US who actually got vaccinated is between 39 and 44%. Since 45% is not in the interval, it's not plausible or likely that that many people got vaccinated. So, if the government was trying to run some ads and see if they were effective, maybe it's not as effective as they would have hoped. So here's the second part of this question. Once again, probably a good idea to pause the video and try it for yourself. Okay, here's where we're talking about sample size like we discussed in class today. So this is our margin of error, z star times the square root of p hat times 1 minus p hat all over n. And I don't know what the sample size is. I'm going to be solving for n, but I have my value for z star. That's 2.576 because once again we're still using a 99% confidence interval. However, as I mentioned in class today, we're not necessarily sure before we do our survey the value of p hat. So to do a conservative estimate, we're going to use the largest product possible, which is 0.5 times 0.5. And we want this to be less than or equal to 0.02. So I did a little bit of algebra, squaring both sides and getting n over on the right-hand side of the equation. And then I rewrite it with n on the left side of the equation. And this says that n has to be greater than or equal to 4,147.36. Obviously, I can't have 0.36 of a person, and I want to be less than or equal to 0.02 for my margin of error. So if I want a smaller margin of error, I'd have to round up to 4,148 people. We will be going over the homework in class on Thursday. Don't forget to work on that, and quiz on Friday.